Hi, this is Alex from devstories.eu. Apache Cassandra with Python, episode 11 of 12. Filtering database records with an object mapper usually feels effortless, letting you search by any field you want. But in Cassandra, if you try to filter on a column that is not explicitly indexed or part of a primary key, the database will flat out refuse to run your query. The solution is understanding how to construct valid requests, which brings us to making queries with cqlengine. In cqlengine, when you want to retrieve data from a model, you interact with a query set. If you have a model representing a database table, you can access records by calling the objects attribute, followed by the all method. This returns a query set representing every row in that table. Pulling every row is rarely what you want in a distributed database, so you need a way to narrow down the results. To restrict the data returned, you use the filter method. A common point of confusion here is how this filtering actually happens. Developers coming from other frameworks sometimes assume the object mapper pulls all the data into the Python client and filters the list in memory. That is entirely incorrect. The filter method maps directly to a strict CQL where clause. This means the columns you pass to the filter method must comply with Cassandra query rules. You can only filter on partition keys, clustering columns, or columns with a secondary index. If you attempt to filter on a standard unindexed text field, cqlengine will not hide the error or process it locally. It will pass the query straight to Cassandra, and Cassandra will reject it. Let us look at a concrete scenario. You have an automobile model and you want to find all cars made by Tesla manufactured after the year 2012. You start by calling objects.filter. You pass the manufacturer keyword argument set to the string Tesla. To handle the year condition, cqlengine provides special filtering operators. You apply these by appending a double underscore and an operator abbreviation directly to the column name. For strictly greater than, you use double underscore GT. So you add a second keyword argument to your filter call, year double underscore GT equals 2012. The mapper smoothly translates this into a valid CQL query. There are several other operators available for different conditions. If you wanted to check for specific car models instead of a year, you could use the double underscore in operator. You would pass model double underscore in set to a Python list containing the names Model S and Model 3. The database will return records matching any value in that list. Here's the key insight. Query sets are completely immutable. When you call the filter method on an existing query set, it does not modify that object in place. Instead, it returns a brand new query set with the additional filters applied. You can create a base query set that only filters for the manufacturer Tesla and assign it to a variable. Then you can use that single variable to generate multiple different filtered query sets for different years or models just by calling filter on the base variable again. The original base query remains completely unchanged. Because query sets are immutable, you can programmatically construct highly specific, complex queries step by step, safely reusing base conditions across your application before any network call is ever made. Thanks for hanging out. Hope you picked up something new.